Number 8 is the last one. Number 8 is about as complex as they get for 2D motion. On the midterm, that is. You folks actually did much harder problems than these when you did the 2D motion section. Actually, if you're looking for stuff to review on the wiki, there should be scads of 2D motion problems. Alright, a scared kangaroo once cleared a fence by jumping with a speed of 8.42 meters per second and an angle of 55.2 degrees with respect to the ground. The jump lasted 1.4 seconds. How high was the fence? What's the kangaroo's horizontal displacement? Alright, so here's our kangaroo. Let's see if I can draw a kangaroo. And a pouch. They're a kangaroo, right? And they have a long flat tail, I think. And there's some arms associated with the kangaroo. And I think they got big ears. At least mine does. And yeah, that face went terribly wrong. But there's my kangaroo. So, the kangaroo is going to jump up over the fence and come back down. So we're going to assume that it hits the fence, or it clears the fence right there at the midpoint. And this whole thing takes 1.4 seconds. So we're going to say that it clears the fence at 0.7 seconds. So that's halfway through. All right. Cool. What do we need to do? Well, we know that it's jumping at an angle of 55 degrees. So this is its velocity vector. This angle here is 55 degrees. The velocity vector has a magnitude of 8.42 meters per second. We need to see what that breaks down into in the y and the x direction. So we got to use SOHCAHTOA. We got to figure out what this is. We got to figure out what that is. So I know that, let's see, the sine of 55 is going to be the opposite over the hypotenuse. Opposite over 8.42. So 55 sine times 8.42 gives me 6.9. So the opposite is 6.9 meters per second. So right here, 6.9 meters per second. Then I could use the Pythagorean theorem, or I could say cosine 55 is adjacent over the hypotenuse. Either way I'll do it. 55 cosine times 8.42, and I got 4.8. 4.8 meters per second. So this down here, 4.8 meters per second. So I broke that velocity vector into its x and y components. Why did I do that? Because I'm going to put them in an x and y chart. Where can I put this x and y chart? Let me take a look at the camera. See how much space is left on the board. Oh, we got tons of space. I'm just using that corner. So we're going to put the x and y chart here. X and y. Okay. In the x direction, the initial velocity is 4.8 meters per second. The acceleration is 0 meters per second squared. What else are we looking for? We'll get back to that one. In the y direction, the initial velocity, 6.9 meters per second. Acceleration, negative 9.8 meters per second squared. And we'll go from there. Okay, so what is the velocity in the y direction at the top here? It's going to be 0, right? So if we say the final velocity is 0 meters per second, we know that occurs, he reaches the top of his arc, or her arc, at 0.7 seconds, which is half of 1.4. So we can also say that the time is 0.7 seconds. And then our givens work out. What are they asking for? What do they want? What do you want? They want to know how high the fence was. So they want a delta y. Can we give them a delta y? Yeah, why not? Let's say we could use this equation. Initial velocity times time plus 1/2 acceleration times time squared. That'll do it. We've got the time, so it won't be that hard to work out. So 6.9 times 0.7 plus 1/2 negative 9.8 times 0.7 squared. We crank all those numbers. 6.9 times 0.7 plus 0.5 times negative 9.8 times 0.7 squared equals, I got 2.43 meters. What do they say? 2.4. Good. We win. Math works. B, what was the kangaroo's horizontal displacement? So when we worry about horizontal displacement, if we did 0.7 seconds, that would just get us how far he went horizontally. We want 1.4 seconds. So over here, we want to look at his total trip, total 1.4 seconds, not this little 0.7 second half. All right, we can use this equation. Change in x is initial velocity times time plus 1/2 acceleration times time squared. We can plug in what we've got, and we know 4.8 times 1.4 will give us the answer that we seek. 4.8 times 1.4 gives me 6.72 meters. 6.72 meters. Like 18 feet. I guess they're big creatures. Okay.